Today, we're diving into a truly terrifying fungal invader. This is a pathogen that WHO actually calls a high-priority threat, and it strikes when our body's defenses are at their absolute lowest. This is the anatomy of mucormycosis.
You know, to really understand our culprit, we have to start right here, in the most ordinary places you can imagine. The molds that cause this disease, they're from an order called Mucorales, and they are literally everywhere. You have probably breathed in their spores thousands of times and never even known it. Okay, but here's the twist. This very common everyday mold is also, as the New England Journal of Medicine puts it, one of the most aggressive pathogens known to medicine. So, what on earth flips that switch? How does something so ordinary become so unbelievably destructive? Well, let's find out.
So, let's put a name to this threat. The World Health Organization, they don't just throw around a term like high-priority pathogen for no reason. But in this case, believe me, it is more than justified. The disease itself is called mucormycosis. And there are two phrases here you really need to lock onto to understand what we're dealing with: rapidly progressive and frequently lethal. This isn't some slow-moving infection. It is a full-blown assault on the body.
All right, so how does the attack even begin? Let's break down the anatomy of this fungal invasion step by step.
It all starts with these tiny spores that we're inhaling all the time. Now, in a healthy person, specialized immune cells in our lungs, they're called alveolar macrophages, they act like little security guards and just clear them right out. No problem. But in a vulnerable host, those guards get overwhelmed. The spores then germinate, and they transform into their truly invasive form, these long branching filaments called hyphae.
And this right here, this brings us to the most crucial point. This is the hallmark of this disease: angioinvasion. This is what makes mucormycosis so incredibly destructive. The fungus doesn't just infect tissue, it goes straight for the circulatory system itself.
And what you're looking at here? These are the actual weapons of the invasion. These broad, kind of ribbon-like structures are the hyphae. And their shape is no accident. It's perfectly designed to burrow through tissue and, most importantly, right into our blood vessels. Once it's inside, the fungus basically hijacks our blood vessels, using them like superhighways to spread throughout the body. This invasion causes blood clots, which is thrombosis, and that cuts off the blood supply. And without blood, the tissue just dies. That whole process is called infarction and necrosis. But remember, this whole invasion can only happen when our defenses are down. So what kind of vulnerability actually allows this common mold to launch such a devastating attack? Let's take a look at the specific risk factors. And look, the core issue isn't just having a quote-unquote weak immune system. The vulnerabilities are surprisingly specific. For patients with diabetes, high blood sugar, and acidic conditions literally act as fuel for the fungus. For trauma patients, the body can go into a state of immune paralysis right at the site of the injury. And what I found really fascinating is that the fungus has this particular hunger for iron, making patients with iron overload just prime targets. And this isn't just theory. During the COVID-19 pandemic, we saw a tragic perfect storm. The high-dose steroids used to save patients from the virus also happened to suppress their immune systems. You add in poorly controlled diabetes, and suddenly you have the exact conditions the fungus needs to thrive. The result was a devastating outbreak with over 51,000 cases in India alone. A life-saving treatment for one disease just opened the door to another. And this problem is especially bad in places like India, which was considered a hyper-endemic area even before the pandemic hit. It's a combination of climate factors and a high prevalence of diabetes, and it means the country's disease burden is estimated to be a staggering 70 times the global average.
So what does this terrifying invasion actually look like in a patient? Well, the signs can be pretty shocking, mainly because they show the deep tissue destruction that's happening just beneath the surface.
This is sinoorbital mucormycosis. It's a common form we see in diabetic patients. The external swelling on the left, that is a dire warning. The CT scan on the right reveals why. The fungus has completely invaded the sinuses and is eating through soft tissue and bone, making its way toward the eye and eventually the brain. And this is where it gets truly terrifying. This blackened, dead tissue on the roof of the mouth is called a palatal eschar. It is a classic, horrifying sign that the fungus has already destroyed the sinus above and is now literally eating its way into the mouth. And this is what it can look like when it gets in through the skin, which often happens after a severe trauma or a burn. This is not a simple wound infection.
That blackened, necrotic tissue is the sign of that hallmark angio-invasion, with the fungus just destroying everything from the inside out.
Okay, so fighting an enemy this aggressive requires a really comprehensive multi-pronged strategy. There is no single magic bullet here. Success depends on what experts call the 5 pillars.
The strategy is intense, and every single piece is vital. First, speed. You have to catch it early. Second, you hit it hard with powerful antifungal drugs. Third, and this is absolutely critical, you have to surgically remove all the dead, infected tissue. Fourth, you've got to reverse whatever underlying immune problem is going on. And finally, you have to correct the metabolic issues like high blood sugar that are feeding the fungus. You need all 5 pillars. Otherwise, the fight is lost.
And let's just focus on surgery for a second, because this is a crucial point. Because the fungus destroys blood vessels, the very highways that drugs use to travel through the body, medication alone often just can't reach the core of the infection. That dead, infected tissue has to be physically cut out to have any hope of stopping the spread.
Now, while those 5 pillars are our best strategy right now, the fight is far from over. Researchers all over the world are working on new weapons and new tactics to try and improve the outcomes for this devastating disease.
So the to-do list is pretty clear. We need faster diagnostics that don't rely on the slow process of growing the fungus in a lab. We absolutely need better drugs. And what's really exciting are these new therapies that either boost our own immune system or they specifically target the fungus's weapons, basically disarming it rather than killing it outright.
So, mucormycosis really serves as a terrifying warning. It's what happens when a common environmental mold meets an increasingly vulnerable person. With our climate changing and a growing population of at-risk patients, the real question isn't just about this one fungus. It's about the next one. Are we ready?